Hello, everyone. So I see I made a mistake. I did not mention lasers in my topic. Do not be alarmed. It's laser technology. But the key difference, it's not about sintering, no inks, and I'll talk a little bit on how it works and what we do with glass in this area. So at Akoneer, we build laser machines, mostly femtosecond, picosecond pulse duration. We have been doing that for quite a few years. We are located in Vilnius. It's a little bit brave to call it laser capital of the world, but if I change that to ultra short pulse laser capital of the world, I don't think anybody can argue. So it's kind of a national tradition to do things with ultra short pulse lasers, femtoseconds. And we are working worldwide, so our machines you can find from Silicon Valley to Japan. So the SAIL technology, which we are introducing here at the moment, most of installations would be in East Asia, with just a little bit in Europe. So let's get to the technology. SAIL stands for Selective Surface Activation Induced by Laser. It was developed in Vilnius in Center for Physical Science and Technology, patented technology, obviously with femtosecond lasers, as I said, a national tradition. So how it works? We have a clean substrate without any pre-processing, no additives, no coatings, etc. So in this case, it's glass. In principle, any dielectric material works. We tested, I don't know, organic materials, probably more than 100 now. Then we pattern it with laser. So we draw, laser marks the pattern where we want the trace to be, including, if needed, drilling vias, processing the backside as well. And after that, we go to the chemical process. So we have a chemical activation, and we have a electroless plating. And in the electroless plating, copper plates only where we did laser processing. So it's kind of opposite to lithography, etc., semi-additive process. And with that, we have a very good adhesion of copper. We have a chemical bond between the copper and the substrate, and including, again, the vias if needed, etc. So we do 2D circuits with that. Here it's copper, nickel, gold, then assembled in standard SMT machine with diodes, kind of a demo for that. Vias, and also 3D surfaces, 2.5D, 3D. We started actually from automotive and MID parts, molded interconnected devices. Now actually moving more to semiconductor packaging and electronics applications. Some of the materials we tested, so of course today is more focused on glass, but as I said, a lot of organic materials, pretty much any dielectric material or semiconductor material off the shelf works. Even some materials that are famous for nothing sticking to them, like Teflon, for example, we can work on that. We did some antennas for space applications on Teflon with our technology. And that's kind of a summary sheet, let's say, of what we can achieve, because after that I'm focusing more specifically on this application with multi-layer glass PCBs. So we can go down to 1 micron trace width. Actually the record, and that's on glass, what we did now is about 700 nanometers. Of course, aspect ratio is a problem because we have electroless plating. I'll explain a little bit. And high adhesion, relatively low cost, very much depends what we compare with. It's probably more costly than screen printing, way less costly than lithography, so really depends on application. Let's go to multi-layer glass PCB. So